Crash Course Instrumentation, Episode 40, Inside the Digital Multimeter, Jacks, Fuses, and Construction. In our last episode, we introduced the digital multimeter. But what's actually going on inside that bright yellow box? And what do all those input jacks mean? Today, we're opening up the multimeter, figuratively of course, to take a closer look at how it's built, how the jacks work, and what makes a good DMM safe and reliable. Let's start with the jacks on the front of the meter. Most digital multimeters have 3 or 4 input jack, and understanding what each one does is critical. COM is short for common. This is your reference terminal. It's where you always plug the black lead. Everything is measured relative to this connection. The V-ohm jack, sometimes labeled VO or similar, is used to measure voltage, resistance, and often continuity, capacitance, frequency, or diode voltage drop. You plug your red lead into this jack for almost everything except current. For measuring current, many meters provide a separate milliamp jack and a high current jack. The milliamp jack is usually fused and intended for currents below about 400 milliamps. The high current jack might be unfused or use a separate heavy-duty fuse for up to 10 or 20 amps, but typically for short-duration measurements only. Using the wrong jack can be dangerous. If you leave your red lead in the amp jack and try to measure voltage, you could blow a fuse, or worse, create a short circuit. So before you make any measurement, look at your jacks and look at your selector knob. Are they in agreement? If not, stop and correct it. What's inside a digital multimeter? Despite their compact size, digital multimeters pack in a surprising amount of tech. Here are some of the main components. A high-impedance input stage is the first thing your signal sees. This is what allows the DMM to measure voltage without significantly affecting the circuit it's connected to. Typical input resistance is 10 megaohms or higher. A rotary selector switch tells the meter what you're trying to measure. It mechanically connects different parts of the circuit to the display processor. For voltage measurements, the signal passes through a voltage divider to scale it down. This makes high voltages readable by the sensitive internal electronics. To measure current, the meter uses precision shunt resistors. These tiny resistors produce a small voltage drop proportional to the current flowing through them. The meter then measures that drop and calculates current. Fuses protect the internal components by blowing when too much current flows through the wrong path. Blown fuses are common and replaceable, but always use the exact type and rating recommended by the manufacturer. At the heart of the meter is a microcontroller or custom integrated circuit that digitizes the signal, applies calibration factors, and drives the LCD display. Finally, everything is enclosed in a rugged, insulated case with shielding to block electrical noise and internal barriers to prevent arcing or internal shorting at high voltage. Safety tip: let the meter do the work. Older meters made you select your range manually. If you guessed wrong, say expecting 20 volts and getting 200, you could overload the meter or misread the value. Modern multimeters feature auto-ranging, which detects the signal and chooses the best range automatically. This protects the meter, speeds up your workflow, and keeps you focused on the measurement rather than guessing the setting. The same principle applies when measuring resistance or current. With auto-ranging, the meter adjusts the display resolution based on what it detects. Bonus tip: when measuring voltage or current, start with the red lead in the correct jack, the selector knob on the correct setting, and the probes, not touching anything until you double-check your setup. Then test. Did you know? The first widely successful digital multimeter was the Fluke 8020A, introduced in 1977. It combined ruggedness, accuracy, and a bright digital display, all in a compact handheld package. This meter set the template for nearly every DMM that followed, and even today, many techs still keep a vintage Fluke around as a backup. Quick recap: COM is your ground or common terminal. Always use it for the black lead. Washer V-ohm is for measuring volts, ohms, and other passive values. Red lead goes here for most measurements. A milliamp and amp jacks are for current. Only use them when measuring current. Inside the meter, shunt resistors, fuses, input protection, voltage dividers, and a processor. Auto-ranging helps avoid mistakes and improve safety. Thanks for watching this episode of Crash Course Instrumentation. In our next episode, we'll start exploring real-world measurement techniques, beginning with how to measure voltage safely and accurately in the field. Special thanks to Tony Kuphaldt and the open-source community behind the ModEL instructional series. You can explore more at ibiblio.org/Kuphaldi/Socratic model. Like, subscribe, and join our growing Facebook group for more instrumentation tips and episodes.